Welcome to Cookie's Maths and Science Hub. Today, we'll be exploring an essential skill in algebra, transposing equations. That's just a fancy way of saying rearranging equations to solve for an unknown. Let's get into it. Before we dive in, let's quickly review the four basic operations in math: addition, subtraction, multiplication, and division. These operations help us solve equations and manipulate variables being our unknowns like x, y, and z, etc. Let's look at an addition in particular. Let's take 5, just the number 5, and add 3 to it. So if we were to write it out as an equation, we would have 5 plus 3 equals 8. Now, for some reason, we might want to get rid of that 3. The way we get rid of an addition is we subtract it away. If I was to write it out, we would have 5 plus 3 subtract 3. Now you will notice this gives us just 5 by itself. If we look back at that initial equation and we look at the other side of the equation, we will see that it is 8. If we subtract 3 from that side, it gives us 5, which in our new equation is the correct answer, because 5 plus 3 subtract 3 equals 5. This is the core concept we will use for transposing algebraic equations. Whatever you do to change one side of an equation, in our example, subtracting 3 from the left, you must do to the other, in our example, then subtracting 3 from the right. This will ensure your equation stays balanced and is correct. It is helpful to remember in these situations that addition and subtraction are buddies, whilst multiplication and division are buddies. If you need to remove an addition from a side of the equation, you subtract the same value, and then do the same to the other side, of course, whereas if you are removing a multiplication, you divide by the same value, and then do the same to the other side, and so on and so forth. Obviously remembering to go the other way if you're going back the other way. Now, using those four basic operations, let's focus on transposing equations, a technique that allows us to solve for a specific variable by rearranging an equation. In the example I have highlighted now, we have 2a plus 5 equals 15. Throughout the next couple of slides, we're going to work on solving for a, that is, finding what value a represents in our equation. Just a few things to remember quickly. Just remember from your algebra basics that you would have completed in class that 2a represents 2 multiplied by the variable a, whatever that variable might represent. Now, variables can be represented by symbols and letters, but most of the time you'll see them either as a or x or y or z. Those are the usual go-to ones. B and C sometimes if there's multiple variables, but we won't get into that for some time. To transpose an equation, we want to get rid of any numbers or terms that don't have the variable involved. In this case, our variable is a. If we look at our a, we can see that it is multiplied by 2 and then 5 is added, which equals 15 in total. Now, when working with transposing equations, you always want to do what's called the constant, or the number that's furthest away from affecting our variable. In this case, again, our a. So, whilst it is multiplied by 2, it is then added to 5. So you want to work in reverse order. So the first thing we want to do is get rid of that 5 that is added to our sum. Going back to our basic operations, how do you think we'll get rid of that 5? If you said we would get rid of the 5 by subtracting 5, then congratulations, you're already making your way well through transposing equations. However, if you didn't get it right, don't stress. You're here to learn how to do it, not coming in because you already know. So we will subtract 5 from that side, and that will get rid of our 5 for us, because if we take 5 from 5, we get 0, which is effectively what we call cancelling it out. However, that crucial rule we said at the start is that whatever you do to the left-hand side, you must do to the right-hand side of the equation. So if we subtract 5 from our left-hand side of the equation, we have to do the same on the other side to keep it balanced. That leaves us with 2a is equal to 10, because 15 subtract 5 is 10, which is what our right-hand side looks like once we have subtracted 5. Next, we aim to isolate our variable a by removing the 2, or what's known as the coefficient, in front of it. Remembering that 2a represents 2 multiplied by a. Thinking back to our basic operations, what was the buddy of multiplication? Division. So in this case, to get rid of 2 times a, we're going to divide that side by 2. Again, 2 divided by 2 gives us 1, or 1a, which is the same as just having a. So again, we have cancelled out that coefficient. That core rule is still in place, however, and we must make sure that whatever we do to the left, we do to the right. I know I'm repeating that rule a lot, but that is the crucial step in transposing algebraic equations. And if you can remember that, and remember the buddies between multiplication and division, and addition and subtraction, then you should be able to do any equation, even the more complicated ones. So that leaves us with a is equal to 5, and we have solved for our unknown variable with just 2 steps. Now, there is one last step that I really recommend doing, which will allow you to check your answer, even in tests, to make sure you've done it correctly. Once you know the answer, we can check by going back to the original equation. We know from our calculations that our variable a is equal to 5. So let us double check to make sure 5 keeps this equation correct. Remembering that 2a represents 2 multiplied by a, then if we substitute in our 5 for that a value, we have 2 multiplied by 5, and then 5 is added to it. 2 multiplied by 5 is of course 10, and if we add 5 to that, we get 15, showing our calculation is correct. This is an amazing way you can check your answer, not just for these simple algebraic equations, but for any such equation where you are finding an unknown. This is known as substitution. Let's look at a second example now. In this example, we have a divided by 3 subtract 4 is equal to 2. If you wish to attempt this one by yourself, pause the video now and have a go. Okay, as from before with our example, it can be helpful to read it out loud to realize which order of the steps you need to do. Remembering, we want to get rid of things, in a sense, furthest away from our variable, in this case, a, first. So, if we read it out loud once more, we have a is divided by 3, then 4 is subtracted. This can be helpful as it allows us to see which step is the furthest away, as it's first divided by 3, then 4 is subtracted. So we're going to get rid of the subtract 4 first. Remembering once more back to our equations and their partners. If we need to get rid of a subtract 4, then we will need to add 4 to the equation. So we add 4 to the left-hand side of the equation, and remembering that key fundamental rule that whatever we do to the left, we must do to the right. So we have cancelled out that 4 and added 4 to the right, meaning we are left with a divided by 3 is equal to 6. Our last step in this equation is to get rid of the divided by 3. Once again, remembering back to our 4 equations, the partner of division is multiplication. If we multiply that side by 3, we are cancelling out that 3 that is dividing our a. And whatever we do to the left, and I know I've repeated this several times now, we must do to the right. That is the key rule. You always must follow it. So that means we must multiply our 6 by 3 as well, leaving us with a is equal to 18. Lastly, much like our first example, it's always helpful to check your answer using substitution. So our variable a is divided by 3, then 4 is subtracted, which gives us an answer of 2. So if we place our 18 in where our a variable is, we will get the sum of 18 divided by 3 subtract 4 is equal to 2. Now, I didn't mention it in the first example, but sometimes these can have multiple more steps than just 2, and you've got to be careful that you're following BODMAS, that is, order of operations, remembering that multiplication and division come first before any subtractions or additions. So, 18 divided by 3 gives us 6. So then we have 6 subtract 4, which is equal to 2. This once again shows us that we have the correct answer as both sides of our equation are equal to one another. Thanks for watching. Hopefully you've come away with some skills that will allow you to easily transpose algebraic equations in the future. Keep an eye out for our second video in this series that will go through some more complex examples. See you soon.